Right. Well, good evening, folks. My name is Himanshu Bari, and I'm here with my colleagues Ilya from Mirantis and John from Hortonworks. I work for Hortonworks. I'm a product manager there. And today we're going to talk about Hadoop and OpenStack. So Hadoop meet OpenStack, or OpenStack meet Hadoop. Well, they met, and they fell in love. And we'll skip the fun part, but we get down to the fact that they decided to get married. And with marriages come a lot of promises. So I'll be talking about the promises that Hadoop made to OpenStack and vice versa. But the good news is that the promises are actually being executed on. So Ilya will cover some details about the integration, the architecture. And John will talk about how we've actually gone forward and done the integration and do a demo. So let's start at the high level first. The first question is, why Hadoop and OpenStack? So in our mind, what Hadoop brings to OpenStack is really a greenfield use case. You see today, both OpenStack and Hadoop are new to the enterprise. And people are asking, give me a use case to try out OpenStack in my environment. And that's what Hadoop provides OpenStack. Again, it needs a scale-out. It has a scale-out architecture. It needs a platform that supports that scale-out architecture. OpenStack provides that to Hadoop. OpenStack also provides a deployment option for Hadoop. Every time we talk to customers ask us about, can I deploy Hadoop in the public cloud? Can I bring it into my private cloud? What are the options there? Well, OpenStack promises to expand those options for customers. And at the end of the day, both are one of the biggest open source movements. So the integration is a perfect way that promises to go about marrying Hadoop and OpenStack. Again, it also serves as a big aggregator for a lot of the ecosystem vendors. So you see the likes of Rackspace, Red Hat, IBM, everybody announcing support for OpenStack, and the different Hadoop vendors going in the direction of supporting Hadoop on top of OpenStack. To that end, we announced a partnership with Mirantis and Red Hat earlier this year at OpenStack Summit. And the goal of the partnership was to accelerate the adoption and development of Project Savannah. What Project Savannah provides is really three important things. So when we, as Hortonworks, deliver this integration to our customers, it's going to have at high level, three important things. The first is cluster templates that simplify the deployment of a Hadoop cluster on top of OpenStack, give you that single-click ability to deploy the cluster. Second is there will be a bridge between HDFS and Swift. So for customers who have the data in Swift and they want to process that data, they will be able to move that data onto HDFS, do their analytics, and then move the results back onto Swift. And the last part is simplified elasticity. So in the next few slides, I'm going to talk about some of the use cases, starting with around provisioning. So when we see customers are trying to stand up a Hadoop cluster in their environment, there's a lot of back and forth that has to go on between the tweaking and tuning of the cluster. There are different types of clusters required for development, for testing, and that just means that it's a big overhead on the operators who are trying to do this process. Again, it's an error-prone process. Every time you try to bring up a cluster, you miss some configuration, you got to go back, fix it, and it just takes a lot of time. So we want to simplify that thing. If you want to migrate from your QA or your staging environment to your production environment, there is no one-click way of taking the snapshot of your Hadoop cluster and moving it to production. We want to solve that problem as well. And also give an option for customers to move away from the existing tools like Amazon EMR. So to that end, in the first phase, we will deliver clusters, cluster templates, node and cluster level templates to simplify the deployment and provisioning. We will allow you to save and export these templates from one environment to another, so you can do those migrations. And in the second phase, we'll provide a job flow-based interface for provisioning Hadoop. Rather, you can upload your data, you specify a job flow, it executes your analytical job, and the results end up back on an object store like Swift. For elasticity, Hadoop is elastic. You can add and remove nodes for sure. But the problem is, if you're running in a virtual environment, when you want to do some maintenance on your physical box or even on the VM, how do you do it in a way in which it captures the end-to-end process? You want a single-click way where you can say, I need to do maintenance on this physical box. Please, whatever Hadoop nodes are running on that hypervisor, decommission those nodes and do it in an elegant fashion. Second is you want an easy way to expand or shrink your cluster, especially in the dev and test environment. And sometimes you want to do it in an automated fashion. If you have an environment that's shared between your Hadoop cluster and your non-Hadoop workload, then you want to be able to define rules that, based upon the resource utilization on that physical host, you can maybe expand or shrink the capacity of your cluster. So to that end, in the first phase of this integration, we will deliver add and remove capabilities from OpenStack natively. So it captures the end-to-end process, right from actually adding or removing the virtual machine to actually adding that node to the Hadoop cluster. And second, it will also have operations like destroy or delete the cluster that you will see in a second. In phase 2, we will focus more on the rule-based elasticity. The last part on the feature set is multi-tenancy. Now, as you deploy multiple Hadoop clusters in the environment, if you are able to create a pool of resources based on virtual machines on which you can stand up all these different clusters, there is a lot of ability to improve the resource utilization. That is possible with this integration. Second is, by function of running within virtual machines, you get some resource isolation just by function of running within virtual machines, CPU, memory, or I/O isolation. And that allows you to support different types of workloads on the same physical resources, or even do things like run multiple versions of Hadoop on top of the same physical resources and simplify the aspect of maintenance. So all of that will be enabled by the features on the multi-tenancy side. So for phase 1, we will make sure that the Hadoop virtualization extensions are part of this integration. Changes needed to the balancing policies on HDFS, task placement policies, changes needed to Yarn to make sure that it understands the virtual infrastructure. We also will provide the ability to pin virtual machines to certain groups of hosts that allows customers, as someone hosting an infrastructure, I need to be able to guarantee SLAs to certain tenants. So I want to make sure that no other tenants' workloads interfere with a group of hosts that belong to a certain tenant. So you need a way to actually pin a VM to a group of hosts to enable that. So we'll deliver that in the first phase. And the last part is Keystone integration. So Ilya will talk a little bit about what are the different OpenStack projects, but the goal of this Keystone integration with Ambari is to provide that single sign-on. So the authentication and authorization policies that you define on the OpenStack side are reflected as you interact with your cluster on the Hadoop side. On phase 2, we have enhancements to integrate Keystone with the job flow-based provisioning that we will enable. So today, OpenStack does not understand the concept of Hadoop job flows. And if you want to do job flow-based interaction with your cluster, then you need to have a way in which you can define authentication and authorization policies for job flows. That will be part of our second phase. So that was a brief snapshot of what are the different feature set and why we are going about doing this integration. I'm going to hand it over to Ilya, who will talk about more details about the Savannah controller architecture.
Thank you, Himanshu. So I'm OpenStack guy on the Hadoop event, so I'll talk a little bit about OpenStack. So OpenStack essentially is a framework to build your own public or private clouds. Sometimes, especially in the early days, it was called like AWS in your own data center. So OpenStack is a fully open source project run and governed by its own OpenStack Foundation, but all the code is licensed under Apache 2 license, so in the governing principles is similar to Apache. OpenStack has a modular architecture, and there is a notion of core and integrated projects. And the core are those that are essentially OpenStack can't run with. So I'll talk a little bit about a few of the most important of them. So compute is essentially equivalent of EC2, and is something that allows you to provide general purpose compute nodes, such as virtual machines. And this has code name Nova. The next one is more interesting. It's OpenStack networking. Now it's called Neutron. Previously it was Quantum. Essentially, it's an API to provide your own private network through software-defined network solution, as well as some of the network-oriented services like load balancing as a service or DNS as a service. So storage are represented by the two of the components, Swift object store, and Cinder is a block storage. All of the services provide REST APIs and manage through the REST APIs. And there is an UI dashboard to manage all of your cloud's components called Horizon, which is essentially a thin layer that use those REST APIs. So the set of integrated projects enhance the capabilities of OpenStack to allow more high-level user-friendly functionality. The examples are Heat for orchestration, which are templates to add template engine to provision all of the OpenStack resources at once, Ceilometer for gathering statistics and metering. And so that's where we see Savanna fit. Mirantis, being a company that had a mission to build production-grade OpenStack cluster, we see lots of customer use cases and demands to kind of provision and operate Hadoop on OpenStack in very native to OpenStack fashion. With keeping in mind, we start building the Savanna is one more OpenStack component integrated to the OpenStack ecosystem. One of the important principles was the plugin mechanism. Many of the OpenStack components has this plugin mechanism to implement different vendor-specific solution implementation, like has Cinder block storage, and Quantum has different implementation of the actual mechanism to work with the corresponding underlying services. So in Savanna, we have this plugin mechanism to work with the different Hadoop distributions. So Hortonworks is one of them, and we are showcasing specifically Hortonworks implementation during this session. Here is Savanna architecture, kind of fancy picture, but what is important, it's kind of built in a fashion that all other OpenStack components are built. It has a REST API. It has its own set of pages on the OpenStack dashboard horizon. It provides internally a set of the services for the plugin to make for the plugin easier to operate in the OpenStack environment. But those services use OpenStack services underneath, like Keystone is used for authentication and authorization, Nova is used basically for compute nodes provisioning, Glance is used for the image storing, and we also provide integration with Swift, which I will talk later. So what are the key features? Those are the key features for the version that we are working right now. It's in progress and will soon be available. One of the key features is template engine. So Savanna has its own template engine to kind of ease the provision of the cluster. And this template engine provides an ability to import vendor-specific template, which enables Ambari blueprints. We also provide manual cluster scaling. I'll talk more about some of the capabilities to enable Hadoop work more efficiently on top of the clouds. So for this phase, we'll come up with two of the plugins implementation. One is Hortonworks Data Platform plugin that you can see during this show. And we'll also have a vanilla Apache Hadoop without Ambari, which will be kind of reference implementation for all of the plugins containing all of the features from the Savanna perspective. But from the Hadoop perspective, it will be based on the pre-built image and will not feature in stuff like Ambari. So what are some of the specifics for running Hadoop in the clouds? One of the things is HDFS reliability. So when you run Hadoop on top of the cloud platform, data nodes are run inside virtual machine containers. And it might happen, if you not take care of that all of the data nodes are placed on the same compute physical nodes. So, and if this compute node is gone, then the data block is gone. You don't want to make it happen. So we'll address it in a few ways. So one of the ways is relatively straightforward, is just not to allow data nodes per cluster, data nodes of one cluster to be on the same compute nodes. So we call it data nodes anti-affinity. Though data nodes from the different clusters can be on the same physical node. The second way is actually more interesting in terms of the functionality it provides. So we implemented file system for Hadoop that can use Swift, which is object store at OpenStack, directly to store your data. And if you have your data stored at Swift, you can just read this data directly from Swift without necessity to it's the local HDFS. Then you can use local HDFS, for instance, on ephemeral drive with replication factor 1 to store the intermediate results and write the final results to the Swift, which is, once again, will be reliable storage. Another configuration option that Savannah provides is HDFS placement. So we'll come out with two of the options. One is the ephemeral drive. Essentially, it's just local disk which comes with the virtual machines, and also block storage implementation via Cinder volumes. The one we are going to support in future along the lines with the Havana release of OpenStack is mounting the spindle from the hardware spindle to the guest operation system and providing it as a HDFS location for Hadoop. So for the next phase, we'll focus on, for the next release, we'll focus on providing job flow, on-demand job flow type of the workload execution when the user will just need to send the jar file with the job or type in Pig or Hive query and have all the cluster provisioning happen under the hood. As well as, very importantly, we'll support more of the configuration parameters and we'll support OpenStack networking. So with this, I'll pass in the presentation to John, who will talk about HDP plugin and will show the demo.
Thank you, Ilya. So my name is John Spadell. I work for Hortonworks. I'm an engineer working on virtualization. We're going to spend a little bit of time talking about the HDP plugin to OpenStack, and we're actually going through a live demo where we're going to provision a cluster running in the Hortonworks lab using the Savannah plugin. So what is the plug? The HDP plugin plugs into Savannah. What is it? Its primary responsibilities are to provision an HDP cluster on top of OpenStack VMs. In doing so, it uses Ambari behind the scenes for almost everything that it does. Ambari is very important to our plugin to provision Hadoop. The plugin works with both standard, just bare bones OS VM images, and we also package VM images that contain HTTP bits to make the bootstrapping of the VM images a little quicker. You could use either. It supports both. It also supports two types of configuration. It supports a standard Savannah-based configuration template. We're going to walk through that in some more detail in the demo. And it also supports Ambari-style templates, also known as blueprints. This is a new feature of Ambari in the future, where you'll be able to export a configuration based on a running cluster. We'll be able to import that configuration and provision a cluster using that. And that's actually what we're going to do in the demo. The Ambari blueprints, there's a link down here. If you'd like to take a look at it, Ambari 1783, you can track the Ambari blueprint work that's being done. OK, so going through the demo, we're going to, let's see. We're going to install Ambari on the VM images as the first step. So when the plugin is called, the VMs have already been provisioned. The first thing that the plugin is going to do is it's going to install Ambari services on all the hosts. So on the master node, it's going to install an Ambari server, and Ambari agents are installed on the remaining hosts. This is based on the configuration where the Ambari server is going to live. At that point, the plugin is going to use Ambari, who's been bootstrapped. It's going to use Ambari REST APIs to provision the cluster, basically defining the topology, configuring the services, starting up the services. After the cluster has been created, we're going to use Ambari to monitor the new cluster. All right, so as I mentioned, we're going to be doing a live demo here based on, and then we're going to be provisioning a cluster on an OpenStack environment we have over in our Hortonworks lab. That's an RDO, Red Hat, OpenStack distribution that we're going to be using there. OK, I talked a bit about blueprints, a little more detail on the blueprints. A blueprint is the configuration for a specific cluster, but it has holes for environmental entries, things that are specific to the environment, like host names, et cetera. So it's a partial configuration. It's not the fully operational configuration. By plugging in these parameters specific to the configuration for the cluster that we're building, now that forms our operational configuration. OK, so we're going to take a look at doing a demo here. So we go to the demo here. All right, so this is, if you're familiar with Horizon, this is the Horizon UI that comes with OpenStack. The project tab and the admin tab here are standard. The Savannah tab, that's new. So under the Savannah tab, as you can see, I already have a cluster that's been provisioned already. We may use that if we run past time. We're going to talk about some configuration here. So that was from my previous run. I'm going to delete that. What we're going to do is I'm going to act as though we have no configuration already, and I'm going to specify a node group. And a node group is basically a role. It's a role that's going to be assigned to a group of hosts. So an example here would be a master and a slave. We have two different types of roles here. And for each one of these roles, we're going to have corresponding components, Hadoop components, that are going to be running on those nodes. All right, so I'll delete the one we have here for slave, and I'll step through how we would actually build one of these. So we come up here and we'll do a create template, specify our plugin, give it a name. We'll just call it slave like we had before. Here's where we specify a flavor. That's a VM flavor. And the components for our slaves. So we're going to pick all these slave components, data node, HDFS client. As you can see, we're using Ganglia here for our metrics, historical metrics. We have Ambari agent, task tracker, and not just, OK. And MapReduce client. All right. So we're going to create that. At this point, we have two node groups, a master and a slave. We're going to come up to cluster templates. So now there's two ways here. We can either create a new cluster template, and in doing so, what we would do is we would specify the node group templates that we just created and how many instances of each we want. So we obviously, for the master, we'd have one, and for the slaves, we could have multiple node groups, and we'd select an image. Where we can upload a template here, and that's what we're going to do in the demo here. We're going to upload a template. This template is an Ambari template, also known as a blueprint that we spoke of earlier. This could be generated from, in the future, work that's being done in Ambari. So you may have a cluster that you want to reproduce. You tell Ambari, export this particular configuration. You come in here, click upload, and we're going to give it a name. Browse. OK, we upload this. All right, so what we just did is we uploaded the HTTP Ambari template, and now we have an OpenStack Savannah template. Give you an idea what's inside of it. So it has some configurations that were contained within the Ambari template, some HDFS configuration, some MapReduce configuration, and some general configuration that doesn't fit in either of those. That's used for things such as our behind-the-scenes Puppet scripts, whatever we needed that didn't fit into those paradigms. All right. It also, in addition to the configuration, it has node groups specified. So we also have a master and a slave here, but these are not the same master and slave from the node group templates. These came directly from the configuration which we have right here. So here's an example of an Ambari template. So this is in flux. This is going to change going forward, but this is operational right now in this particular environment. So we have some stack information. We've got services listed, and we have components that are available for each of the services. So we have HDFS, and for each of the components, it specifies the allowable cardinality. And we can also specify configurations here if we choose to at this level, which we haven't. We also have MapReduce with some components. Down here, we also have host role mappings. Host role mappings act like the node groups where so in this case, master consists of these particular components, has a cardinality of 1. We only want one master. We've got a slave. We have 1+ for cardinality, so it makes sense to have more than one of these slaves. And at the bottom, we're going to have various configurations. These configurations are what we just displayed. Okay, so at this point, we're ready to go ahead and create a cluster. So we come up to here, we're going to click Create. Cluster name, we'll call it we selected our HTTP blueprint here. That's the template that we just created from the Ambari template. We're specifying a base image. In this case, we have some of the HTTP bits already installed on the image. To speed things up a little bit, like I said, we can either use an image that we have provided and bundled with the plugin, or we can use a raw OS image, just a CentOS 6 image or a RHEL image. And we would then, in the absence of having the HTTP bits already deployed, we would then go ahead and obtain those from a public repository. And we've also specified a key pair here that we've already registered with Savannah and with OpenStack. So, all right, we're going to click Create. All right, so we're going to go through several phases here. The total time for this takes about 10 minutes here. As you can see, we have 3 particular instances we're going to create, the master and 2 slaves. It's going to go through various phases. If we could go to the slide deck. Okay, so we can specify node group templates, cluster templates. At this point, we've uploaded an Ambari blueprint. All right, so at this particular phase right here, what's happening is Savannah is provisioning the VMs. It's going ahead and spinning up 3 VMs, doing what's necessary to provide connectivity between those VMs. All right, so at that point, we wait until we have network connectivity. Once we have network connectivity, the HTTP plugin will be invoked. So if we go back to the demo. All right, so we're in a waiting state here. So if we come over, we can take a look at the project tab under instances. You can see here, so HTTP cluster was our cluster name. We have 3 of these. They're active. At this point, we're simply waiting for network connectivity so we can connect to those VMs. OK, so now we're in the configuring phase. If I go back to the slide deck. In the configuring phase, that means that the VMs have been provisioned, and we've been able to connect to those VMs. So the network's been set up. The first thing that we do in the HTTP plugin is we are going to provision Ambari. So through remote SSH calls, we're going to install Ambari server on the master as it was declared in the configuration, and we're going to install the Ambari agents on the remaining slave nodes. We're going to sit in this mode until all the agents and the server have come up and the agents have registered with the server. At this point, we have Ambari already installed on the images, but if they weren't, they would also be installed from a public repo. All right, once we're able to connect to Ambari, the remaining calls are all going to go through the Ambari REST APIs. From that point on, we're just dealing with Ambari REST from this point on. The first thing we need to do is we need to define the topology of the cluster to Ambari. So through various API calls to Ambari, we're going to specify the topology. And as you see here, that information is then pushed into a database, the Ambari database. By default, it's a MySQL database running on the same VM. Okay. Once the agents are up and we have full connectivity, we're going to, once again, using the REST APIs, we're going to tell Ambari through the REST APIs, we're going to tell it to install the relevant services on each node. So Ambari is going to go out, if it needs to the public repos, install the HTTP bits to the VMs, or it's going to grab them locally from a local repo. At that point, once the bits are in place, it's going to push configurations to each node, so each agent is responsible for configuration of its own node. This installation step is the most lengthy step of the process, and it's asynchronous. So what we have to do in the HTTP plugin is we'll the call immediately returns, and we'll sit using the API, we'll spin until that status changes to a completed install. And finally, once the installation is complete, we'll return flow back to the Savannah controller. You'll see the state switch from configuring to starting. At that point, the plugin will be invoked again. We'll tell Ambari, go ahead, start all the services. When the services are completed, then we have a running cluster, and then we can use Ambari to then go ahead and monitor the cluster as if it was provisioned by hand. So we go back here to the demo. As you can see here, we're still configuring. But what I'll do here is I already created a cluster. The whole process takes about 10 minutes. We have a few minutes left here. Why don't we go ahead and take a look at the cluster 1 here that we had provisioned earlier. The first thing we need to do is we need to look at the instances here. OK, so in cluster 1, what we're going to do is we're going to, on the master, we're going to assign a floating IP so we can connect to it. Okay, so now we have a public IP here. We're going to come over to Ambari. Running on the default port here. Oop, hold on, forgot pound. OK, so you can see we have HDFS running, MapReduce running. We can look at our hosts. So we have cluster 1 master, cluster 1 slave, cluster 2 slave. In addition to that, we can go back here and we can look at services. So in HDFS, you can see that it has Ganglia data available in graphs. You can click on the graphs to see more detail. Oops, where's the button at? All right, I can't seem to find my button. All right. So back to where we were. I won't bring a big screen up again. It also provides heat maps, so you can take a look at the various hosts and see what state they're in for various metrics. So in this case, let's say if we want host memory used. So the master is using more memory than the slaves at this point in time. It gives you a good overview of what state your hosts are in. And once again, we can look at services. So if we go back now to the actual demo here in Savannah, you can see now that the new cluster, the HTTP cluster, is in the starting state. So we're in the process of starting that. While it's starting, we'll go ahead and look at the various other pieces of data available here from under the Savannah Hadoop tab. So we looked at this one, the clusters, that's the running clusters, or the clusters that are actually in progress. We looked at cluster templates and no-group templates. In addition, it has an image registry. So these are images that have been stored in Glance that have also been registered with Savannah. And we also have a list of plugins. At this point, the HTTP plugin is the only one that's been installed. OK. Can we go back to the demo? I'm sorry, the slide deck. Thanks. So we've monitored the cluster here via Ambari. You can also use the Ambari REST APIs, which I'm not going to show, to also monitor the cluster. Everything that you see in the Ambari UI is going through the REST APIs, so you could feel free to write your own UI using those REST APIs. There's no magic there. All right, so that concludes the demo here. Well, if you want to Yeah, okay, that concludes the demo. So basically, what have we shown? We've shown provisioning an Ambari cluster on top of OpenStack in a repeatable, simple fashion using the Savannah UI, using template-based configuration. And all right, we'll open up the questions now. Yes.
No questions.
No questions?
There's one question.
So I have a couple of questions. First, how are we ensuring data locality?
Data locality for what?
For HDFS. Like, and the whole idea of Hadoop is you bring the computation to the data, and the data is on local disks. So how are we ensuring that here in this platform?
So right. So there's two options essentially when you run Hadoop on the cloud. There's several options where the actual HDFS is located. So one of the options is just to use local disks of the virtual machine, so-called ephemeral drives. Then data locality can be like easily achieved by just passing on the information on what are the physical hosts and what are the actual virtual hosts the corresponding job, the corresponding Hadoop service is running. So it's essentially, when you're using just ephemeral drive, it's essentially the same as you're running on the just normal environments. The question then, when you use like remote service, like block storage through Cinder, then you obviously may lose your data locality because the service will be remote via the network. So one piece that we actually done is when you use Swift, we've provided a patch to Swift that exposes information where the data in Swift is located, actual nodes. And Savannah pass on this information to Hadoop scheduler. So if you design the underlying, like cluster, OpenStack cluster topology in a way that compute and storage node can be collocated at least on the rack level, then this information will be passed on to the Hadoop scheduler, and you still can take advantage of the data locality.
So Ilya, if I can add something there, right? So net is that after you provision the cluster using this whole process, it's basically like a regular old Hadoop cluster, right? I mean, you have a virtual machine, it has local storage, you got your compute and data running in that virtual machine. So there's no difference. So you still have the data locality that you're talking about.
Okay. And what if you're running other services on top of this, like HBase, for example? How would that work out? Because data nodes can go off and come on at any point in time, right?
Right. I mean, if a data node goes off and comes back again, from a Hadoop's cluster standpoint, it's just like the node going and coming back in the physical world, right? When the node comes back, if it has data, then from HDFS standpoint, it's a new data node. So it's going to do all the rebalancing that it has to do that it already does in the physical world. So nothing changes from that standpoint.
Okay. And so, for example, I have HBase running as well, and I co-locate it with the data nodes. So anytime you scale up or down your cluster, you're actually moving a lot of data, right?
Yeah. So if you were to add a new node to your cluster, and that cluster has that new node actually has the locally attached disk, it is a data node, or it's a new HBase node, it's a new region server. I mean, there is going to be data movement just like it is there today on the physical world. So, yeah.
The important thing to note is that although we're provisioning on top of VMs, we're still going through the Ambari REST API. It's really no different than if you were doing it through the Ambari UI. At that point, the fact that it's on a virtualized world is pretty much hidden from that point on and acts as if you had provisioned it by hand.
Hello, my name is Zoran. I work for DDN. This is really interesting stuff, but I still had a question. So one of the value proposition that, let's say, Amazon would have with their EC2 is the dynamic control of the cluster. Of course, they charge money for it. And I was wondering, are there any plans, so if you have anything that you can like shrink or reduce the Hadoop cluster? It's not going to be anywhere fast, but if you need the capacity, if you detect
Yeah, so that is part of the plan. Initially, when I was talking about elasticity, there would be a way to add a new node to the cluster. And it's actually even better than like doing it on a physical Hadoop cluster, right? Because in the physical world, you got to have that server provisioned, take the host ID, and then add it to the cluster. Here, you can just go into this UI and say, add a new data node to my Hadoop cluster, and it will take care of the whole process end to end. It'll actually provision the VM, install the data node bits on that VM, and commission that node as to be part of the Hadoop cluster. And then HDFS will do all the rebalancing behind the scenes.
So, and for the scaling of the size of the cluster, we support manual scaling right now. And we have plans in future for dual scaling as well.
So based on some kind of policies, fully automated, I assume?
Yes.
Yeah, that's in the kinds of more distant plans. But yes, we have this in mind.
OK, cool. Thank you.
Thank you.
So do you always need Swift with the OpenStack? So in this case, in this cluster, I have 2 storage systems here, Swift and HDFS?
Yeah, so the answer is no, you don't need Swift, right? But if you are an OpenStack customer who has an object store like Swift installed and you already have data in Swift, and then if you want to do some processing on that data, then this gives you that option of bringing that data into your Hadoop cluster, doing the processing, and copying the results back. But Swift is completely optional.
OK, so if I'm just running OpenStack and Hadoop, I don't need the Swift.
Oh, absolutely, yes. Yeah, sure.
I had a couple questions. One was about performance of the disk reads. Did you say a bare disk is coming in OpenStack as an option? Like you could have a VM request its own spindle just for itself?
Yes, it's coming in the future OpenStack releases. It's not there yet, though.
And the second one was, how mature is this, and how close is it to someone using this in production?
Right. So at Hortonworks, I mean, we are at the point where we did the first demo of this feature. Our plan is to do GA by the end of the year. So that's where we stand today. We're not at a point where you can do a beta. So yeah.
So Hortonworks has its plans for this enterprise-ready version, but like open source Savannah project has its own roadmap. And we plan to do a release of the stuff that we're showing right now in a few weeks, in the mid-July. And as part of the open source initiative.
So the key thing to note here is Project Savannah has this controller and plugin architecture, right? So the controller is something that's going to provide all the feature set for all the different plugins to live together. And the plugins plug into that controller. We as Hortonworks will make sure that our plugin works with the controller, test, document, go through our usual process of releasing anything that we release to the enterprise, and then make it available to our customers. And that plan is for the end of the year. OK?
So you said that there are two interfaces for this project. One is for management of the clusters. You're using Ambari.
Mm-hmm.
So for each cluster, do you have to basically instantiate that UI, or?
Yeah. So right now, you need one Ambari instance per Hadoop cluster. But the plan going forward is on a per tenant basis. So in OpenStack, you would have multiple tenants. For a given tenant, if that tenant has multiple Hadoop clusters, then you should be able to manage that from one single instance of Ambari. So that's where we want to get to.
OK, so that means that you will have one instance of Ambari running.
Yes, you have to have one instance per tenant, because you don't want to mix data from different tenants in the same instance of Ambari.
But you said you have the plans to build one instance for multiple clusters, right?
Yes, that's right.
Most of that limitation is Ambari right now. It only handles a single cluster. That's why you have a single Ambari instance per cluster.
So from a physical versus virtual management standpoint, is there any difference in the behavior of Ambari, or is it exactly the same the way it's done in physical world?
It's exactly the same.
Yeah.
Exactly the same.
Yes.
Yep, we're using the same REST APIs behind the scenes that the Ambari UI uses.
Talking about OpenStack and physical versus virtual, physical bare metal provisioning is coming in OpenStack, and we definitely will be supporting that. So it'll be another interesting use case for Savannah together with HDP plugin and Ambari.
Cool. I guess no more questions? Well, thank you very much, guys.
Thank you.
Thank you.